Okay, now what we're going to do is take a look at some specific examples and see how we can take some shortcuts. So what I have set up here is a one-term polynomial, okay, where I can take a look at it and that n could be any value, a could be any value, and I have an example here like a could equal 5, it's not a variable. We have x, n would be 4 here, okay. Now, the general form of what we have here, okay, and there's a couple different ways that we're going to write this. Okay, first of all, I probably should go over how to write a derivative. Okay, so now y is equal to f of x. Okay, so now a couple different ways that we can do this. dy dx is one way to write the derivative. That's going to be f prime of x, or sometimes you'll see it as y prime of x. Okay. For the most part, just to really kind of hammer into your head that you're looking at derivatives here, I'm probably going to be using mostly this and this. Okay. In a couple cases, I won't, just so we can see it for brevity. But these are going to be the two that we probably look at the most. So now, if y is equal to ax of n, dy dx, the derivative of y, would equal n times a times x to the n minus 1. So now, what that would equal? So if I take a look at this, y is equal to 5x to the 4th. dy dx would equal n, which is 4, a, which is 5, x to the 1 lower power, which is 3. So in this case, it would be 20x to the 3rd. Okay? So that's your first time you've taken a derivative. Okay? Like we did in the previous example, where I said that in the previous lecture, where we went through and we did by definition x squared, and we found out it was 2x. You took a derivative at that point, but you did it by definition. This is the first time that you're doing it by the shortcut. Okay? So now, let's just take a look at another example. Okay? Let's just say y is equal to 3x to the 20th. Well, dy dx would equal 20 times 3 times x to the 1 lower power, which is the 19th. So it would be 60x to the 19th. Okay. Now, let's go over a couple of rules here. Let's just say y of x is equal to a of x plus b of x. Now, I used to hate this when I'd be in a math class. I'd be like, what the heck's a and b? I don't know what's going on. So let me give you an example of what I mean. I'm sorry for erasing the most recent example, but so now, let's just say y of x, as the example, equals 5x squared plus 3x to the 4th. Okay? So this is going to be where all the general forms are. This is where we're going to put all of our specific examples. Y prime of x, or let me just put it as dy dx. dy dx will equal dA dx plus dB dx. In English, all you're going to do is take the derivative of each and add them together. So what does that mean? Okay, that means that the derivative of dy dx here is equal to,
Can I have a custodian to the main office, please?
I still can't get away from the announcements. Okay? Multiply by the power, that's going to be 2 times 5 is 10. X to the 1 lower power is 1. Plus, multiply these together, 12x cubed. Okay? This is just derivatives of by addition. Okay? And then this would be your derivative. Okay? And there's lots of examples, and you could add on, a third and a fourth and a fifth and a sixth term, but it just all works that same way. Whenever they're just added together, it's a very easy derivative to take. So now, let's say we have a more complicated situation. Okay. Hit pause for a second because I'm going to erase all this off. Make sure you get everything down. If ever you're falling behind on something that I'm writing, make sure you pause for a second. So now, here's our general. Here's our specific. So now, let's just say y of x is equal to ax times bx. Specific example, let's just say y of x is equal to 3x times 2x squared plus 3.
Rob Parker to the main office.
Something I have to go over here with you guys really quickly too. Okay. So now, yes, I could definitely multiply these together and just have it be a polynomial and do what I did before. But we're just trying to see an example of how this works. Okay. There's definitely examples where you can't just multiply it together. If I put a sine x in there, which we're going to learn about very soon, it would be very hard to do that. So now, dy dx here will equal a of x times db dx plus b of x times dA dx. Okay, let's just see how this works. Okay, so now I'm going to say here a of x will be my 3x. B of x will equal 2x squared plus 3. Now, see, I still
Rob
can get away
Parker
from it.
or custodian, please come to the main office in reference to a delivery. Thank you.
Now, once you get used to this, this will be much easier to do very quickly. However, I'm going to break it down step by step by step until you, and you should do that too until you feel comfortable with it. Okay? So now, this is going to be a of x. So my dy dx here will equal a of x, which is 3x, times db dx. Now, here's where I have to go over something with you guys. db dx. Okay? So now, that's going to be the derivative of this. So now, this is just going to be, right here, this is 4x. Okay? Now, the derivative of a constant. There is no x there. Take a derivative with respect to it. Okay? The derivative of a constant, in this case the constant is 3, is 0. Okay? So the derivative of 4 is 0. Derivative of 100 is 0. No matter what I did, if I did a graph of that, okay? Remember, this is just saying like y equals 3. Okay, y equals 3. right there. What's the slope of that line? 0. Let's say if it was 100. What's the slope of this line? Still 0. So now, my dB dx, therefore, is just 4x. Okay? Plus b of x. 2x squared plus 3 times dA of x. So now dA dx, derivative, okay, so now the implied end here is 1. So 1 times 3 is 3. To the 1 lower power, x to the 0 is 1. So dA dx is equal to 3. So now dA dx times 3. Now, if you leave it like that, you can simplify a little bit. I'll go ahead and simplify just a little bit. dy dx is equal to 12x squared. I'll distribute the 3 plus 6, x squared plus 9. So I get 18x squared plus 9. And you leave it like that. Okay? So that's the product rule. Okay? The quotient rule. A little bit more involved. Okay? The quotient rule is, let's say we have y of x is equal to a of x over b of x. Now, I'm going to give you something that would be very easy to solve just using other methods. However, it just shows you the process of going about solving the quotient rule. Okay? So now, let's just say that y of x is equal to 6x to the third over 2x. Now, let's just figure out what this is initially. Let's figure out the easy way first, just so we can see that we come up with the right answer. So if I simplify this, this would be saying y is equal to 3x squared. And I know that dy dx would equal 6x. Okay? So my answer, whatever I do, better wind up being 6x. So let's take a look. Okay? My derivative here, the general form of the derivative, dy dx, will equal b of x times dA dx minus a of x dB dx all over bx squared. That's kind of crazy, but we'll just go with it. Okay, so it's the first times, it's the second times the derivative of the first minus, I should say the derivative of the numerator, minus the numerator times derivative of the denominator divided by the denominator squared. Okay. Sometimes it's easier to set this up as a product rule and make this be to the negative value, whatever it is. Sometimes it's not. Sometimes you have to go through this quotient rule. Okay. So now, let's take a look.
Rob Parker or a custodian.
I swear, it still doesn't get, I can't get away from it.
Thank you.
So my a of x is going to be 6x cubed. My b of x is going to be 2x. So now, dy dx will equal b of x, which is 2x, derivative of ax. So now, 3 times 6 is 18, x to the 1 lower power squared, minus a of x, 6x cubed, times dB dx. So this is Okay, 2x derivative of that is just 2. All over this term squared. So that's going to be 4x squared. So now, let's simplify and see if we wind up with 6x. If not, then I'm going to have to stop this and flip some terms around and everything. So now this is 36x cubed minus 12x cubed all over 4x squared. The x squareds are going to cancel out 2 of those. So now what I'm left with is dy dx is equal to 36x minus 12x over 4. That's 24x over 4. Okay? Divide 24 by 4 and get 6x. Okay? So that's the quotient rule. Okay? All right, I'm going to show you one more example. Okay? And it's a very important example. Okay? This is the chain rule. So after this, we're going to, this will be the last part of this segment. All right? Pause if you haven't written everything down, because I'm going to erase the board. So now, let's take a look at a chain rule. Chain rule is very important. And especially important once we get into sine and cosine. Because there's lots of cases there where you have to, and exponentials, where you're going to have to put it together. Okay? Chain rule says something like this. Let's just say y of x is equal to a of b of x. I gotta tell you, whenever I saw the general form of the chain rule, I always looked at it and go, I don't know what that means. So we definitely have to take a look at a specific example here. So let's just say my specific example here will be 3x squared plus 5 cubed. Okay? So now what I'm going to do, what I have in here, I have this function nested inside a cube function. Okay? So I'm taking x, I'm squaring it, I'm adding 3, multiplying it by 3, I'm adding 5 to it. That's my b of x. My a of x then is cubing it. Okay? So now, I have to figure out what the derivative of this is. And by the way, as a good exercise, I would go ahead and cube this term out, figure out what the derivative of the polynomial is, and see if you wind up with the same answer. Okay? So now, dy dx, okay, it's going to be, try to think, make sure that I get this right in the general form. The derivative of b, so it's going to be dv dx I'm going to pause it and I'm going to come back to you in just a second. No, I'm just going to leave it like this. All right, I'm going to have to edit out that last portion.